develop our own solution. If such solution can help you solve the problem in running, I will be very interested. First, our company, Antiware, is founded in 2007. And currently we have around 450% in our company. Among them, more than 52% are from R&D department. And each year we invest around 10% in R&D department. Now we have two factories. Both are based in Suzhou area, only around 1.5 hour driving from Shanghai International Airport. And both sites have around 100,000 square meter workshop. During the past years, around maybe 5 or 6 years ago, we have only revenue around $100 million. Last year, 2025, we get around $460 million. We mainly serve for like refinery and chemical, metallurgical, and oil and gas, and maybe fertilizer. And mainly supply bars and butter bars. In China, we are very well known due to many civil application bars. In export business, we can supply many bars, including the titanium metal steel ball bar, amethyl slurry fluxion bars, and PFA line bars, and the check bars. Today, I will share our solution only for titanium metal steel ball bar. As you know, the application here is very critical. It's including binary slurry with sulfur acid. And the pressure from 0.5 to 5.5 mg. And the temperature is also very high, more than 200. The highest is 275. 1 year is cycled around 500 times. In this area, as far as I know, there are only two suppliers supply the titanium metal steel ball bar, but both has only around maybe 6 to 12 mass service life. And we have many experts to repair these bars. Both we found the final problem is jamming and internal leakage. And we did a lot of research and look at why it gets internal leakage and jamming. And we found that because the fluid is acid mineral slurry, so you must be in the hard coatings. Normally, for such fluid, the coatings are titanium dioxide or chromium oxide. But both coatings are very hard, and their melting temperature is very high. So normal HVF supersonic process cannot be used. Only plasma coating process can be used in this area. But plasma process has a big problem because the porosity of the coating is very high. Sometimes from 0.8 to maybe 3 points. And also, as you know, the titanium material, basic material titanium, is very light and very soft. But the coating is very hard. So between the hard coating and the soft basic material, we have to find a bonding zone to connect the hard coating and the soft basic materials. Normally, the material is tantalum because tantalum has a very good bonding characteristics to connect the soft one with the hard one. So it's a basic structure of the coating. And then we found the cross-portion procedure of the whole story. Because, the porosity of titanium dioxide and chromium oxide is around 1%. So, sometimes the acid will enter the basic coating, through some voids into the tantalum and maybe the basic material. For the bonding material, tantalum, it is a very good resistant, but the temperature cannot exceed 150 degrees C. If the temperature is higher than 150 degrees C, its corrosion resistant ability will get down very easily. So, as you know, the working temperature at the core is around 250 to 275. With high temperature, the acid will enter and approach the tantalum through the voids. And finally, the tantalum will proceed. And as a result, the refraction of the material happens. And then the coating will be cleaned off from the skin surface. That's why we found the coating get peeled from the skin surface of the ball and the seeds. So depending upon the last analysis, around 4 years ago, we set up our own objectives of titanium solution. That means the lab has to run online at least 2 years. And we set up some indicators like its corrosion rate should be below 0.1 millimeter a year. And its operating torque and leakage before API 598. And after 1,000 cycles, the stable will completely. And around 2 years ago, finally we found the coating, what we call FS54. And its corrosion rate is below 0.1 millimeter a year. Its hardness is over 840 HB, and its friction coefficient is around 0.05 to 0.8. And its porosity in the key index almost 0. And also, this kind of coating, because the coating is a mixture nano coating, so it has a very low frequency coefficient. That means the fluid is very difficult to adhere on the sealing surface of the coating. It's a comparison between the indicators of titanium dioxide and chromium oxide and our own coating FS54. As you can see, the hardness rating of Floyd 54 is 842. This is the hardest one. And although its bonding strength is not so high, it's only 71 MPa, but the main point, the porosity of FS54 is almost 0. So that means the coating and the bonding material will be fully perfectly protected by this porosity. So we organized our testing plan to